Good afternoon. Welcome back to the chemical bonding. And yesterday we have seen bond angle, bond order, bond length, and bond enthalpy, and all. Now we will see the polarity of bonds, dipole moment, and all. Why it is required at the end of the this thing. I will tell. Now what is the polarity? See, if it is an ionic compound, it is very clear. The one is electronegative, another is electropositive. So electron is transferred. Whereas in the ionic, other than the ionic, covalent compounds, there will be a polarity. Example, hydrogen fluoride. So fluoride is more electronegative and compared to hydrogen, so there will be a partial charge. That charge will be represented like in the arrow mark, and electron pairs will be towards the fluorine, towards fluorine. So there will be a polarity on the fluorine. So there is a polarity, positive here and negative here. This will be represented by one Peter Debye scientist as a dipole moment. Dipole moment is symbol is mu equal to charge into distance between the two nuclei. That will be the normally unit. This is called mu is a dipole moment, dipole moment unit, and the units are Debye's. And the name of the scientist, same thing is Debye. 1 debye equal to 3.3 into 10 to the power of minus 30 coulomb meter. That will be this thing. So this will be the dipole moment and all these things. Now why this dipole moment and all everything is so important? It is so important in the chemistry point of view. Is see H2O. So H both are H only. So it should be a linear compound. But unlike a linear, means it is not a linear, it is having a 104 degree, it is not a 180 degree and all. Like that, many compounds having a different shape than the predicted. Experimentally, it is the different from the predicted or theoretically and all. Then comes to the what is the shape of the molecule. And whereas this Lewis octet rule and all, they are not given the clear cut about the shapes of the molecules. So to find out the shapes and all, in that process, this Debye has found out the polarity of it. Because of this polarity, there are many things has happened. So hydrogen H2O is not like this. It is like a X structure. Okay, fine. Then also why there is a polarity? The polarity is because here the electron pair is pulled this side, that is called a vibration, and at the same time this will be pulled like this. So it will be going on resonance. This is one type, or otherwise one can be like this. Hydrogen, it is pulled, and another hydrogen is pushing. So resultant will be like this. So dipole moment will be a change of polarity, and because of the bending. In higher classes, you will come to know what is the binding vibration, what is the linear vibration in this. Finally, you will have a change in dipole moment. Because of change in dipole moment, the shapes are fixed. Means that is because of what we will see in the valence bond theory and all. So this is about the polarity and dipole moment, and many compounds are experimentally. Suppose beryllium fluoride, that is a linear. Beryllium fluoride is a linear, whereas boron trifluoride is not a linear. It is having a boron trifluoride is a again dipole, total dipole moment is 0. BF2 is also 0, whereas ammonia and carbon tetrachloride and all not having dipole moments and all. So finally these shapes and all these things will be Faison, as Faison one rules are there. It has given some rules. We will see what are the rules. For a given cation, if cation is fixed, covalent character increases, increasing the size of the anion. Cation is same. Anion is we are increasing. The anion size, with increasing the anion size, the covalent character is increasing. Meaning is potassium is constant cation, fluorine means potassium fluoride and potassium iodide. Fluoride, iodine is the more atomic number, so covalent character of Ki is more compared to the Kf. That's what is one of the rules. For a given cation, fixed cation, covalent character increases with the decrease of size of the cation. That means reverse now. Fluorine anion we are fixing, and cation we are changing. That means same fluorine I will take, Kf and lithium fluoride. This is higher, bigger the cation, low, smaller the anion, smaller the cation. So this will be the covalent character will be the other side, reverse. Covalent character. Lithium fluoride is more covalent compared to the Kf. Okay. So these are the second rule. And similarly, covalent character increases with increasing the charge on either cation or anion. That is SN4, SnCl4 or SnCl2, like this thing. So this will be the some of the Paschen rules. Then valence bond theory has come. Why? Because the octet rule of the Lewis and other people could not tell about the shapes of the molecules and all. So now here rule number 1 for this is the valency shell electron repair repulsion theory has come into the picture. Rule number 1, the shape is depending on lone pairs. Lone pairs around the central atom. Shape is depending on lone pairs. Lone pair means you remember oxygen. If you see O2, O and O double bond. Here the two lone pairs are there. Here two lone pairs because outside. But talking about the valency. Out of 6, this thing. 4 is 2 is participated and this thing. Like this, this is the lone pair of the electrons on that. So rule number 2, lone pairs, that means electrons repel each other, like poles each other. Okay. So then, because of this reason, they will try to be away as far as possible. The lone pairs repel each other. Because of this reason, they will try to accommodate as far as possible. That is the next rule. Then multiple bond is treated as single bond. Multiple bond is taken as single bond for this purpose. Taken as single bond. Then, so here now repulsive interactions, electron pairs decrease in the order. Suppose there is a one lone pair is there. Lone pair repulsions are lone pair is more than lone pair. Only one is having lone pair. There can be a homonuclear, heteronuclear order. So these combinations will be lone pair repulsions are more than lone pair and bond is more than bond. Okay. Here also electrons are participating one, pair. So this is having more repulsion than compared to this. So because of these reasons, all the shapes are participating. Okay. Now we will see some examples. Okay. Only small examples we will see. Why the BF3 is angular and why BF boron chloride, dichloride, beryllium chloride. Beryllium is like this, like this, chlorine, chlorine. It will be the why lone pair, where the lone pair and all these things we will see tomorrow. Similarly, BFP3 lone pairs and CH4 or CH4 or PCl5, why the shapes are coming, because of this we will see tomorrow. Then there are again some problems and all. So then a valence bond theory has come. Then to overcome that and all these things, there will be again some more corrections. So molecular orbital theory. So it is all improvement over the science. Science is a regular upcoming or updating and all these things. So why all these things? Yes, we will see the load pairs, and because of load pairs and repulsions and screening, so many theories will be there. Thank you.